Hello everyone. In today's video, we are going to solve a British Math Olympiad problem. So the problem is very clear and very basic. It is given as a fraction of two really big numbers, and we have to solve this without using calculator. Okay. So suppose you don't have a calculator with you, but you have to find out this fraction or this quotient. Okay, the bigger number above in the numerator is 1 to the power 4, which is nothing but 1, but 2007 to the power 4 plus 2008 to the power 4, they are fairly big numbers. And in the denominator you have 1 square plus 2007 square plus 2008 square. Okay, well, so we have to find what is the value of this quotient. Okay, so the given expression I have recorded here, and in this case you see there are some connections between these two numbers, these three numbers actually. So 1 2007 and then 2008, so 1 plus 2007 is 2008. Okay, so if we take one of them to be x, then so basically bigger to be x, then it is fairly nice and it will be in a compact form. Okay, therefore we take x to be 2002, and the equivalent expression in terms of x becomes this 1 to the 4 on square as it was, as they are, and then 2007 is x minus 1, right? So x minus 1 whole to the 4, and 2008 is just x, so x to the 4, and 1 square here, and this is x minus 1 whole square, and this is x squared. Okay, yeah, fine. So this is now a simpler form to handle. Okay, so 1 to the power 4 is 1 to the power 4, and then x minus 1 whole to the power 4. It is very easy to write all such powers, so it becomes x to the power 4, okay, minus 4 is the power, so 4c3, which is 4, okay, x cube, plus, so the signs are alternative for minus 1 to the power something. Okay, so this is fine. So plus 6x square next term, because 4c2 is 6, and then minus 4c3x, 4c3 is 4, which is 4x, and then plus 1 to the power 4, which is plus 1 simply, and x to the power 4 it was already here, so x to the power 4 remains unchanged, and then 1 square plus x square, 1 square plus x square, they remain unchanged, but x minus 1 whole square, I can actually write it in this form, x square minus 2x plus 1. Okay, so this is nothing but, from this step, if you just write x minus 1 whole to the 4 here in the numerator and x minus 1 whole square in the denominator here, you get this expression, nothing complicated here. Okay, so what is the next step? In the next step, you see that 1 to the power 4 is 1, and this plus 1 is there, and x to the power 4, one of the x to the power 4 is there, and then another x to the power 4 is here. Okay, so if we just simply add them without doing any trick, you get 2x to the power 4 minus 4x cube plus 6x square minus 4x plus 2, and in the denominator you get x square plus x square, which is 2x squared minus 2x, and then 1 square, 1 plus 1, which becomes 2. Fine. So now it is an easy observation here, is that the 2 factors out from numerator as well as the denominator. Okay, so factor out 2, then what you are left with is simply this. So x to the power 4 becomes 2x to the power 4 becomes x to the power 4, and then this is minus 2x cube plus 3x square minus 2x plus 1, and in the denominator x square minus x plus 1. Okay, so now this is very interesting expression, we will record it here. Okay, so now what to do? Actually, one can do the division. Okay, using division algorithm, one can just divide the above polynomial by the denominator, but we'll use some trick to solve this. Okay, so x to the power 4, x to the power 4 as it is, since these coefficients are 2 or the 1 like that, so we want to break this up into 2 and 1. Okay, so 3x squared can be written as 2x squared plus x squared minus 2x plus 1 as it was, and in the denominator what you write is x square minus x plus 1 can be written as minus of x minus 1. Fine, there is no problem. So now x to the power 4 can be written as x square whole square, then minus 2x cube plus 2x square plus, you see that x square minus 2x plus 1, right? So we can write x minus 1 whole square. So now you see that x minus 1 here, and then x minus 1 whole square here, and then x square here, and then x to the power 4, which is the x square whole square here. Okay, so that is what I have written here. And then if you see, for this term it is square, for this term it is square, and it whether it is minus 2ab, we have to just check. Okay, so for simplicity, here we first take common 2x squared from here, and you get x minus 1. Okay, so just put x minus 1 equal to maybe x minus 1 equal to b I am putting here, and x square here, this term or this term I am putting a here. So what it becomes, this expression a square, this is x square whole square, so a square, and then minus 2x square into x minus 1. So x square is a and x minus 1 is b, so minus 2ab, and then plus x minus 1 whole square is b square, and what you have here is just a minus b. Perfect. So now if you see, in the numerator you have what? You have a minus b whole square, and then in the denominator a minus b, which is nothing but just a minus b. But a was x square, b was x minus 1, right? So this is nothing but x square minus x minus 1, which is just x square minus x plus 1. Okay, so now what we get is x square minus x plus 1, but the value of x is 2008. So the expression becomes, after replacing the x value, it becomes 2008 square minus 2008 plus 1. Well, so you can actually do this computation by hand, but if you don't want to do, still we can do this 2000 basically 2000 plus 8 whole square, right? That is exactly 2008 whole square. So from this it will be very easy to write the numbers. So 2000, like a plus 8 is b plus a plus b whole square, right? So a square, this is easy to calculate by hand, and then this 2ab, okay, plus b square, which is 8, and then minus 2008 and plus 1, right? Okay, fine. So now this square you can easily compute. Okay, this is 2 square 4, and then 3 zeros, so 6 zeros. So 4 and 1 2 3 4 5 6 6 0, right? This is also very clear. 2 into 2000 is 4000, and 4000 into 8 is 32000. Clear? 8 square is 64. Everything is done. Fine. So now these two numbers you can add very easily. 4032000 minus this number plus 64 plus 1. You can just simply by hand calculate. It's 1943, and then do this minus. So basically it is 2000 in the last digit, and it is 1943 here in the last 4 digits. So it is clear that you will only have 57 here for the last 4 digits, and then 403 as it was, right? And therefore this is the final answer. So this is very not very easy to calculate by hand if you directly want to do the computation, but with some trick you do not actually need a calculator, and I can solve it very peacefully and very easily, no problem in that. Yeah, so that's all in this video. If you like the content, do press the like button and subscribe our channel to motivate us. I sincerely thank you for watching this video.